Hello all, welcome to MATHSOLOGIA. In this video, we discuss problems on exponential probability distribution. In the last video, we discussed mean and variance of exponential distribution and also the introduction with few important examples. So first problem, the length of the telephone conversation in a booth has been an exponential distribution and found an average to be 5 minutes. Find the probability that a random call made from this booth ends less than 5 minutes between 5 and 10 minutes. Exponential distribution is used to model the time between the two events always. When it comes to any experiment that depends on time, then we can use exponential distribution. Here, let x denote a continuous random variable. Okay, we know that exponential is a continuous distribution. Here given average, that is a mu is given here 5 minutes, but we know that mu is equal to 1 by lambda. In the last video we derived this proof, or lambda is equal to 1 by mu, so lambda becomes 1 by 5. The PDF is given by, the probability density function is given by f of x is equal to, we have lambda into e power minus lambda x for the limit 0 less than or equal to x less than infinity, 0 otherwise means minus infinity x less than 0. So therefore we can write f of x is equal to, see, you can neglect this part, anyway it is 0, neglect it, no need to write also when writing. F of x is equal to 1 by 5 e power minus lambda is 1 by 5, it becomes x by 5, x greater than or equal to 0. So this is your PDF of exponential distribution. So given the mean value, find the lambda value and just substitute that in the PDF of exponential distribution. Now coming to the problem, we have to find the probability that a random call made from this booth ends less than 5 minutes. See, average call is 5 minutes. Okay, how many number of days we don't know, it can be for 1 year or 1 day, 2 day, anything. But when a call is made from this booth, what is the probability that a call ends less than 5 minutes? We have to predict that. For this prediction, this exponential distribution plays important role. So ends less than 5 minutes. First question is probability the call ends in less than 5 minutes, right? Less than 5 means p of x less than 5. You should write like this. P of x less than 5 means, if you draw the number line, we have 0 here, 5 we have here, minus infinity plus infinity. Less than 5 means here lowest limit is minus infinity and highest limit is 5 according to this interval. Less than 5, it goes to the left till minus infinity. Then we have to integrate the function dx. But in our PDF, the lowest number is 0, right? 0 less than or equal to x less than infinity. So we have to remove this minus infinity. In place of that, we write 0 to 5. In place of f of x, you have to write the PDF 1 by 5 e power minus x by 5 dx. We cannot write minus infinity because PDF is defined only starting from 0. Lowest number is 0, so we write 0 here. Now doing this integration, 1 by 5 keep as it is. Integration of e to the power minus x by 5 is e to the power minus x by 5 and divide by x coefficient. X coefficient is here minus 1 by 5. The limits are from 0 to 5. We can cancel this 1 by 5, minus outside and put the limits here. upper limit is 5, lower limit is 0. So we would get here e power minus 1 minus 1. You can multiply minus inside the bracket, it becomes minus e power minus 1 plus 1. So using calculator, we can find this. Here we know what is E. E means 2.7182. It continues like 7812 something. That is E. In calculator, we can directly type this E and minus 1 to the power minus 1. It will show the value. The answer is 0.3621. Means what? 36.21%. So 36% chances are there the call will end in less than 5 minutes. Only 36%. So that is the first question. Second question, here we have to find random call in this booth ends between 5 and 10 minutes. So between 5 and 10 minutes, it can end in 6 minutes, it can end in 8 minutes, so it can end in 10 minutes also, right? So between 5 and 10 minutes, what is the probability that call will end? That we have to find. So probability between 5 and 10 minutes. So between 5 and 10 means we have to use this symbol. 5 is less than x, less than 10. See, in this continuous distributions, we can write like this also. It doesn't matter. Okay, don't get confusion here. You can write here equal to sign, or you can write p of x less than x less than or equal to 10. You can write p of x 5 less than or equal to x less than 10. For all the things, the formula is same itself. Integral 5 to 10. We have both 5 and 10, right? We have the end points, lower limit, upper limit, and just integrate f of x dx. Substitute the function we have 5 to 10. Function is 1 by 5 e power minus 1 by 5x or x by 5 dx. Just we have to integrate this between the two limits. We will get the probability answer that the call will end between 5 and 10 minutes. Just integrate that equals to. So 1 by 5 keep as it is. Integration of e power minus x by 5 is, and limits 5 to 10. Cancel this 1 by 5, 1 by 5, but minus is there. Carry it to the numerator. Put the upper limit minus 10 by 5 minus e power minus 5 by 5. Upper limit, lower limit. This equals e power minus 2, e power minus 1. So we can multiply inside minus sign. It will be minus e power minus 2 plus e power minus 1. So the answer will be 0.2325, or you can write 23.25%. So only 23% chances are there the call will end between 5 and 10 minutes. So waiting time, we have to wait. Okay, 23% chances are there the call will end between 5 and 10 minutes. So this is about the first problem. All these problems are applications only that comes under exponential distribution. Next, similar to this, we have one more type in different scenario, that is based on the shower. In a certain town, the duration of a shower is exponentially distributed with the mean 5 minutes. What is the probability that a shower will last for 10 minutes or more? Okay, less than 10 minutes, between 10 and 12 minutes. It is similar to the previous problem. There it was a call problem that is made from some booth. Here it is a natural phenomenon problem that certain tone, the duration of shower is exponentially distributed. So given, right, given mu is given here 5 minutes. Therefore, lambda is 1 by mu. So 1 by mu means 1 by 5 about. Now the PDF is, write the PDF of exponential distribution. Fx is equal to lambda into e power minus lambda x, where x is greater than or equal to 0, lambda is 1 by 5, e to the power minus x by 5. 0 less than or equal to x less than infinity. See, both are same. Okay. Here I wrote in this form, here I wrote in this form. Both are not the same. Next. What we have to do? We have divided the probabilities one by one. First question. Probability of 10 minutes or more means P of x greater than or equal to 10. So greater than or equal to 10 means it starts with 10, ends with infinity, right? Because maximum is infinity here. Again, if you draw the number line, we have 0 here, we have 10 somewhere here, here infinity minus infinity. So 10 to infinity means starts from 10, ends to infinity. So therefore we write interval here 10 to infinity. And then we have to integrate the function f of x dx. F of x is here 1 by 5 e power minus x by 5 dx. Do integration 1 by 5 e power minus x by 5 divided by minus 1 by 5 limits 10 to infinity. 1 by 1 by 5 cancel out, minus outside, e power minus infinity minus e power minus 10 by 5. E power minus infinity value is 0. The minus into minus is plus. We get e power minus 2 is your answer. E power minus 2 gives 0.1353. That's it. Second question we have to find here. Probability less than 10 minutes and then between 10 and 12. Less than 10 minutes you have to find out here. So probability x less than 10 minutes. Less than 10 minutes we have to take here 0 less than x less than 10, right? So for reference, it's better if you write the number line. Less than 10 starts with 10, goes till infinity, but we cannot take infinity because in our problem 0 is the lowest point. So we take 0 here. So limits 0 to 10 f of x dx. Substitute the function. We have 1 by 5 e power minus x by 5 dx. Integrate. So we get divided by minus 1 by 5 and 0 to 10. 1 by 4 by 5 cancel out, minus outside, and put the limits e power minus 10 by 5 minus e power 0. So it is minus e power minus 2 minus 1. Outside we have minus sign. The answer will be here 0.8647. See here probability is 86.47%, very high probability. Out of 100 means it is very close, 86%. So 86% chances are there. The shower will last between, less than 10 minutes. The last question is probability of that the shower lasts between 10 and 12 minutes, right? This was the question. Between 10 and 12 means we should write integration of f of x dx between 10 and 12. So f of x here, the same thing, 1 by 5 e power minus x by 5 dx. Do integration, 1 by 5 constant, integration of exponential, you divide by the coefficient and 10 to 12. So cancel this 1 by 5 and 1 by 5, minus sign outside, e power minus 12 by 5 minus e power minus 10 by 5, upper and lower limit. So here e power 12 by 5 means it will be 2.4, e power minus 2. Here we get 0.0446. If you can write, it is 4.46%, very less probability. The probability that a shower will last between 10 and 12 minutes, between 10 and 12, is just 4%. So this is the second question. Next we have, this is quite different question from the previous two questions. The sales per day in a shop is exponentially distributed. They mention clearly it's exponential distribution with the average sale amounting to rupees 100. Some shop is there and average sale is amounting to 100 rupees. Profit is 8%. Net profit is 8%. Find the probability that the net profit exceeds 30 rupees on 2 consecutive days. Okay. Here, the PDF. First, you write the PDF here. The PDF of exponential distribution is f of x equals to lambda into e power minus lambda x, right, where x is greater than or equal to 0, or bracket you write 0 less than or equal to x less than infinity. Here first we have to find lambda value. To find lambda, we have the relation lambda equals to 1 by mu, and mu is given here in the problem itself, average sale amounting to 100 rupees, so 1 by 100, or you can write 0.01. So this is your lambda value. Therefore, f of x will become 0.01 into e power minus 0.01x. So the formula is created here. Okay. Now, net profit is given here to be 8%. Okay, 8% is given. Net profit of sales 8%. And here find the probability that the net profit exceeds 30 rupees. Okay, here you have to find probability of net profit exceeds rupees 30. This is the question. Here, one side they have given net profit 8%. They are given in terms of percentage. But here the question is asked in rupees. Both are not matching, right? Here percentage we have, here rupees we have. So you have to convert it into same unit. Correct? So we have to convert this percentage to rupees or rupees to percentage. Both should be same. And they clearly mentioned 8% is the profit. But for what amount? We shall take it as let A be the amount for which profit is 8%. Okay, 8%. Now 8% of the amount is 30 rupees. So this is the step where you have to be very careful. Okay, one side 8% they have given. 8% of what amount? We don't know. That is only A here. And the profit in rupees is 30 is given. So 8% of that amount is what? 30 rupees. So 8 divided by 100 into A equals to 30. So A equals to 30 into 100 divided by 8. So calculate this. Here you can cancel 4 into 25, 4 into 2. Here 2 times 2, 15. 15 into 25 will be 375. So this is the amount of sales for which net profit is 8% or 30 rupees. If the sale is 375 rupees, your profit will be 30 rupees or your profit will be 8%. Okay. Now the question is what? We have to find the probability the net profit exceeds 30 rupees. Now, probability that net profit exceeds 30 rupees means definitely it is equal to sales exceeds 375 rupees. Both are equivalent. Finding The probability that net profit exceeds 30 rupees is nothing but finding the probability that sales exceeds 375 rupees. So we have to find here probability of x greater than 375. Okay, greater than 375 means start with 375, end is infinity, integrate f of x dx. Substitute the f of x function, we have 0.01 into e power minus 0.01 x dx. Now simple integration gives here 0.01 into e power minus 0.01 x divided by minus 0.01, and the limits are 375 to infinity. You can cancel this 0.01, and then minus will be there, put the limits, minus 0.01 into 3.75. E power minus infinity is 0, and then minus into minus plus, and here minus, here 375, right? This is not point here, it is 375. So here it is 375. The next step we can write 3.75. So here 375, and here minus minus plus, and 0.01 into 375 is 3.75. This is your answer for on 1 day. Answer for 1 day here. In the question we have to find probability that the net profit exceeds 30 rupees on 2 consecutive days. Today and tomorrow, like that. Consecutive means what? Today is Monday means tomorrow Tuesday. 2 consecutive, like that. Next. So here on 2 days, 2 consecutive, one after another, that is called consecutive days, the profit exceeds 30 rupees is the answer what you got in the previous step. For 1 day, it is multiplied again. That gives answer for 2 consecutive days. It will be minus 7.5, and it will be 0.00055. This is quite logical question. It is different from the last 2 questions what I have solved. Some conversions has to be done here to understand the problem. Yeah. So you have to understand the problem by studying 2 or 3 times. Then it will be cleared. Thank you.